Hello, my name is Raquel Diaz, and in this video, I will show you how to analyze proteomic data using the TransProteomic pipeline, also known as TPP or Petunia. In a proteomic study, we start with a sample that consists of unidentified or unknown proteins. During the sample preparation, these proteins are broken into polypeptides by a protease enzyme. Then the mass spec machine measures the mass and ionic charges of those polypeptides. This data is named as mass spectrum or MS. Using TPP, we can analyze this mass spectra and identify which are those proteins present in the proteomic sample. The mass spec data comes from the machine in a raw mass spec format. This format is not supported by most of the analysis tools. So in the first step, we're gonna use the MS convert to convert this raw mass spec data to a supported format known as MZML. In the next step, we'll search our mass spec data using a reference database of protein sequences. Xtendon will take the proteins from the database and simulate their mass spectra. And these simulated mass spectra will be compared to the ones in our mass spec data. These initial results are not so reliable, so in this step, different scores and probabilities are calculated so the results can be refined. This will increase the number of correct results, removing most of the false positives. So peptide profit will calculate a more accurate score than the e-value provided by Xtendon. E-value is an estimation of the chance of having a false positive result. And I-profit increases the number of correctly identified polypeptides by calculating a very accurate probability that combines multiple polypeptide identifications using their mass spectrum and their ionic charge information. And in the last step, the protein profit will perform the protein assignment. Protein assignment consists of identifying the proteins by merging the polypeptide identification results from peptide profit and I-profit. This step will use both the mass and ionic charge data combined, also known as MS-MS. This will generate the final list of proteins identified with accurate probabilities calculated for each protein classification. In this tutorial, I'll go over the most critical steps for identifying the proteins in your proteomic sample. But TTP has a lot of useful tools, like the file browser, where you can manage your data, upload your input files, and download your analysis results. Another interesting tool is the PEP3D. With the PEP3D, we can generate plots that will summarize the mass spec data by measuring the abundance and the probability of each polypeptide identified. For this tutorial, I'll be using a real example with mass spec data from Liberibacter crescens obtained from a proteomic experiment in our lab, and its reference protein sequence database from the UniProt server. You can access the TPP by navigating to this link in your web browser. TPP and all the input files are already available online, so it's not necessary to install anything in your computer. Okay, so this is the login window. Here you should input your username and password that you have been using for the previous tutorials. So this is the interface of the TPP pipeline. TPP actually is not just one pipeline, but it's a set of different types of pipelines. So the pipeline we're going to be using for this tutorial is the Tandem, which is the most recent and comprehensive pipeline to analyze mass spec data. So once we select the Tandem pipeline, we're going to have this menu item available. which consists of most of the tools we're going to use for this tutorial. So I'm going to click here in the Analysis Pipeline tandem, and then I click an MZML button. So here it's going to show the menu of conversion from the thermal raw format that needs to be selected here to the MZML format. Here we click in Add Files so we can select which is the raw data file that we want. When we click in Add Files, a file selection window will show up on the screen. So here in the right side of the window, you're gonna see a list of usernames. You're gonna select your username from this list by clicking on it. In my case, I'm gonna select my username, that is guest. So you're gonna see a list of files on the left that belong to this directory. Always check that your username show up here. Once you are in the right place and you can see the input file that should be named as vsf1.raw. So now you can click on the input file and click on select. So you're gonna see here the path and the name of the input file that you have just selected. Here you don't need to click in anything, and you just click in convert to MZML. So this step is gonna take that raw file that we provided, that we obtained from the Mass Spec machine, and it's gonna convert to a different language that is supported by the proteomic pipelines, the MZML format. And you click on convert. When you click on convert, it's gonna show another window that shows information about the jobs that are running right now. So you're gonna wait a little bit, and this running is gonna change to finished. So once the job is finished, we can follow to the next step. In the next step, we're gonna do a database search so we can identify all the proteins that are present in our proteomic sample. So for doing this database search, we're gonna mouse over the Analysis Pipeline tandem again, and we're gonna click on Database Search. This is gonna show a database search window. It consists of 3 input files and 1 option and a search button. So in the first item, we're gonna add the MZML file that we just generated in the previous step. So you click on Add Files. It's gonna show a window for selecting the files. So you should be able to see the MZML file right here. And for selecting it, you just click on the selection box and click on the select button. In the second item, we're gonna provide a default parameters file. For doing that, you click on Add Files, then you click on the Data folder, and then you click on the Parameters folder. That should be right here. In the Parameters folder, you should be able to see the tandem params file. So you select this file and click on the Select button. For the third item, we're gonna provide the database file, which is a list of protein sequences that are classified by the UniProt database. So you click on Add Files, and you select the lcras uniprot.fasta file. Then you click on the Select button, and all the input files should be showing up here. Now the last thing you have to do is to select the option Convert Output Files to PEP.xml. This will allow us to see the results in a summarized format. Now the last thing we have to do is to click on Run Tandem Search. This will lead us to the Jobs window that will show a new job running. Once the job is finished, you're gonna see two files around here. If you don't see those files, you can click on refresh or view and they should show up. So the main results file is the pep.xml file that we can visualize by clicking in this link. So when we click in the pep.xml link, it's going to open a new window with a summarized table that shows all the results of the database search process. On the first column to the left, you can see the mass spectrum ID, and in the protein column, you can see the protein classification that match to each mass spectrum from the proteomic sample. So here, for example, we have this mass spectrum that matched to an aspartate tRNA ligase of Leberibacter crescens. In these columns, you can see different types of scores. These scores are proportional to the accuracy or to the quality of the match between the mass spectrum and the polypeptide from the database. But here we don't have any probability values calculated for the results that we have obtained. So in the next step, we're gonna validate our results calculating the probability of each protein classification in our database search results. So for the next step, we're gonna close this window and we're gonna go back to the TPP pipeline and we're gonna click on the Analyze Peptides button. It's gonna show a window for selecting input files and running options. So you're gonna click on Add Files, and then you can select the PEP XML file that we have just generated in the previous step, and you click on Select. Most of the options we're gonna leave as default. We're just gonna select Run Peptide Profit and Run Interprofit. Then we're gonna click on Run X Interact. It will show up the jobs window again with the new job running. When the job is finished, you can click on refresh and it's gonna show a results file named as interact.pep.xml. So you can click on the pep XML link and it's gonna open a new window with a result table that is very similar to the table that we have seen before, but now it has an extra column on the left that shows the probability calculated for each result. So in the next step, we will refine these results. So we're going to close this window. I'm going to go back to the TPP pipeline, and we're going to click on Combine Analysis. And in this window, we're going to click on Add Files, and we'll add the interact.pep.xml file. Just click in the selection box and click in Select. The other options will not be changed. So just click on Run Interprofit. And once the job is finished, you're going to click on Refresh and you're going to see that a new file has been generated. And now for finishing this refinement step, we're going to go back to the analysis pipeline and we're going to click on Analyze Proteins. So we click on Add Files and we add the interact.ipro.pep.xml that has just been generated in the previous step. So we click on Select and then we click on Run Protein Profit. Once the job is done, we're going to have our final table with all the probabilities calculated for every classification result. For visualizing the results, you can click on the Beta link and it will show a table in a new window. In the first column is the protein ID from the UniProt database. In the second column is the protein classification or the protein name. And in the third column is the final probability calculated. So if you go to the Filter and Sort menu, you can select the minimum probability that you want to filter your results and the maximum probability. Then you click on Filter will show a new table with all the results you selected. And we end up with a list of all the proteins that were identified with a high probability in our proteomic mass spec data. So that's it. I hope you enjoyed this video. If you have any questions, please leave your comments and check a detailed PDF tutorial that is in the description of this video. See ya!